Okay, so this is an inscribed circle, and that's a triangle. Now this happens to be a 3, 4, 5 right triangle. So this is the right angle here, and this is going to be the side 3. This is the side 4, and that's the side 5. All right. Now if you want to figure out the area of the triangle, the area of the big triangle, right? This is the area of the triangle, is going to be 1/2 times the base. The base is 4. And the height of it's going to be 3. And 2 goes into 4 2 times, and 2 times 3 is 6. So it's 6 square units. Now, then what I'm going to do now is I'm going to divide this thing into 3 separate triangles now. And the way I'm going to do that is take perpendiculars to the sides of the triangle, at the right, and then over here, perpendicular. It's to the center, and over here, perpendicular. This is R, this is R, this is R. And what I notice over here is I can form some pretty simple triangles now. And there's 3 of them. All right, I see 3 triangles over there. I'm going to do one at a time. And I want to do this one first over here. All right, let me get my pen out. And I'm going to say the area of the first triangle I just put down over here. What's it going to be? 1/2. The base is going to be 4. But now I don't know the height. The height is R. And by the way, R is the radius of that circle. What's it going to give me? 2R. All right. Let's do the next circle. I'm going to talk about this one over here. All right, that's blue. And I'll just say it's the area of the second triangle. That's 1/2. Its base is 3 times R. What do you get there? 3/2 R. All right, let's do the next triangle. This one over here. Oops, let's go to green. This triangle over here. There's 3 triangles, and I hope you realize they're filling the entire space at this point. So let's put that A3 down. What's that going to be? 1/2. Its base is 5 times R, and that's going to be 5/2 R. Now, if I add these 3 triangles together, A1 plus A2 plus A3, what am I going to get? AT. So let's write this down. 2R plus 3/2 of an R plus 5/2 of an R would equal 6. All right, now I'll be able to figure out R now. And what do you get over here? Well, you get 3/2, 5/2, 8/2, 4/2. So you get 6R. Now let me check that again. 3/2, 5/2 is 8/2. 8/2 is 4. 4 plus 2 is 6. 6R. What's R? R is equal to 1. So the radius of an inscribed circle for a 3, 4, 5 has a radius of 1. All right, now this sets up the generalized problem. And the generalized problem is going to be this guy over here, which I'll go to another video to do this one over here. So I'm going to derive this formula here by doing essentially the same thing we did over here. Now, someone says it's a specific case. You should do a specific case before you do a generalized case. Now, this specific case relates to a right triangle, but the bottom line is you could derive it for any triangle, and it really boils down to the same exact thing. And what's that going to be? You take the triangle, whatever it is, you get the total area, and if you got a circle tangent to those sides, it's called inscribed, and it's going to have some radius over here, and you're able to figure this thing out. But again, we'll go to the whiteboard to do the actual problem now. Thank you.